Hello everyone, welcome to our group. Today we will introduce the use of derivation formula in life. There are 3 people in our group. I'm Gloria, Leslie, and Echo. Firstly, I will introduce the introduction and the definition. Then Leslie will introduce questions and solutions. At the end, Echo will do the solution too and the conclusions. In economic life, people often encounter optimization problems, such as the most profitable operation, the highest production efficiency, materials used the least, need to find the best programs and strategy. The derivation is one of the basic ways to solve the problems. We are an advertising agency and we plan to invest in advertising. We found 2 professionals to assess for us how much we'll pay to get the most out of our money. Using derivatives can solve some basic problems in economics. Today, our problem is to use derivatives, and we need to find the max-minimum value. Therefore, when we find the derivatives, we know when the function is the largest to provide enterprises scientific and reasonable data to get the production.
Alright, thanks for Gloria speaking. And next, I will share an example that how to use derivation formulas to solve the problems in our life. For example, there is a company to invest some money for advertising promotions every year in order to obtain more benefits. After investigation, if we set up the invested cost is $10 million, it can increase sales by about the minus t squared at the 40, and the t greater than or equal to 0, less than or equal to 5. There is two questions right now. The first one is that if this company will control advertising cost less than $3 million in this year, so how much advertising cost does this company invest? It will be get the most benefits. How to solve this question? Firstly, we need to know a formula. Is that the benefits equal the sales minus invested cost. And then we can set up the advertising revenue as $10 million, the increase of income is FT. And then we can get the benefit is that the FT equals the minus t squared at the 40 minus t. And then we can get the result as the negative t minus 2 squared and at the 4. By the way, the t greater than or equal to 0, less than or equal to 3. So finally, we can get the t equals $2 million. The FT gets the maximized value is $4 million. So it's clear to show us when the t equals $2 million, the company can get the most benefits. And the question 2 is that this company is ready to invest $3 million for advertising promotions and technology upgrades. After investigation, the company invest cost set up the X million dollars. It can increase sales about this formula. Therefore, please design a capital allocation program that help to make the company obtain the most benefits. My partner Echo will give the solution for you guys. Thanks.
Thanks, Leslie's asking. We just focus on the second problem. Set the capital which for technological transformation for X million is to be used for advertising promotion for 3 minus X million and the X between 0 and 3. The second step set the resulting perform to gx, and the gx can write down here equal to negative 1 of 3x cubed plus 4x plus 3. And so gx equal to negative x squared plus 4. Put the gx equal to 0, we get the true solution, and they are 2 and negative 2. But we just consider about 1x between 0 and 3, so the x equal to negative 2 is impossible answer. We can look at the picture, and gx is on the graph of the function. We can see 1x between 0 and 2, the gx is more than 0. It means it's increasing function. And 1x between 2 and 3 is decreasing function. We can get a conclusion: 1x equal to 2, gx has maximum. At last, the company should use 2 million for the technical transformation and 1 million for advertising and promotion. I made a summary about how to use the derivation formula to deal with the company management problem. The first one is establishing a vocational relationship. The second one is find the instrument point and determine the maximum or minimum. The last one is regression optimization scheme. Okay, thanks my partner Gloria and Leslie. Thanks your attention.